This video begins a new topic in calculus. We've been doing differential calculus, finding derivatives, applications of derivatives. Now we're starting integral calculus. The first topic in integral calculus is the antiderivative. What is an antiderivative? It's when you're given a derivative and you have to find the original function. We're going to do some of these. The first one should be pretty easy. In the first one, you recognize this derivative. You know what this is the derivative of. This is the derivative of x cubed. You know, part of what you know is that if you have x squared in the derivative, you must have x cubed in the original function. Of course, our rule is to take one away from the exponent. But we also remember that we take the exponent and bring it down to be the coefficient. So the derivative of this function x cubed, y prime, is 3x, and then we take one away from the 3 squared. And we're going to do that each time just to make sure our answer is correct. If our answer is correct, its derivative will match the derivative in the original question. Okay, so let's do the next one. The next one is just plain x squared. We don't have an automatic memory of what function has a derivative that's just x squared, not 3x squared, just x squared, 1x squared. Well, we know there still has to be an x cubed in here. But the derivative of x cubed is 3x squared. And if we want to turn 3x squared into x squared, you know, we're going to take the derivative of this. What do we have to do to it? This is that derivative. To get just x squared, what do you do to 3x squared to get x squared? Well, you divide it by 3. So if I divide this original function by 3, maybe that will accomplish the same thing. By the way, notice that this x cubed over 3 is the same as having the 1/3 out here as a coefficient times x cubed. Sometimes it's easier to think about the derivative using this equation. So the derivative is going to be y prime. It's going to be 1/3 times the derivative of x cubed, which is 3x squared. And here we see the 1/3 does its job. 3 over 3 is 1. And the derivative of 1/3 x cubed over 3, is just x squared. Okay, so we did what we said. We took the derivative of our answer and we checked that it matched the derivative in the question. Okay, now we're going to do one where the coefficient is a little more troublesome looking. We have a 5 here. If we have a 5 in the answer, maybe we have a 5 in the original function. Now we know the antiderivative of x squared is x cubed over 3. So maybe if we just multiply that by 5, it'll work. Well, let's try it. What's the derivative? Well, we're going to multiply 5 times the derivative of x cubed over 3. Oops, I made a mark on it. We figured out the derivative of x cubed over 3 was just x squared. We did that above there. So I guess we're correct. We brought down the coefficient and took the antiderivative of x squared. The derivative we get of our answer is the same as the derivative in the problem. Okay, now we're going to try our first polynomial, 2 terms. Now here we know the antiderivative of x squared is x cubed over 3. So we just have to figure out the antiderivative of 2. Now, if a function has a derivative of 2, it has a constant derivative. And what kind of function has a constant derivative? A line, a linear function. And so perhaps it's the line 2x, or the line 2x plus 3, or the line 2x plus 11. All of those would have a derivative of 2. The derivative of x cubed over 3, we've done it a few times now, is x squared, and the derivative of 2x is 2. Now, in many situations, to do the antiderivative, you just have to remember. You have to remember that the derivative of sine is cosine. So the antiderivative of cosine has to be sine. There's no way you can do this unless you remember your trig derivatives. And finally, for this last problem, the answer is the function you love to hate, the natural log function. Something you have to remember. If y equals the natural log of x, its derivative is 1 over x. So this was your introduction to antiderivatives. You have a worksheet with a few problems to try, and then we will discuss all your questions.